Welcome to Fun Facts Online. Today we are going deep into the fabric of reality to discuss a discovery that dismantles the single most persistent illusion of human existence, the flow of time. We are talking about the dissolution of time as a rigid unidirectional river. Recent breakthroughs in quantum physics, specifically the landmark 2025 study from the University of Surrey and the theoretical framework known as the Two State Vector Formalism, have shattered the classical glass ceiling of temporal mechanics. We are going to explore a microscopic universe, or microverse, where time is not a straight arrow flying from the past to the future, but rather a dual-flow highway, where the future can influence the present just as much as the past does. To understand why this is such a radical shift, we first need to understand why physicists have been embarrassed by time for centuries. If you look at the fundamental laws of physics, like Newton's laws of motion, or Einstein's relativity, or even Schrödinger's equation, they are all time symmetric. This means they do not care which way the clock ticks. If you video record a planet orbiting a star and play it backward, the physics works perfectly. However, our lived experience is nothing like that. If you video record an egg smashing on the floor and play it backward, the physics looks broken. Shards of shell do not spontaneously leap from the floor to reassemble themselves. This creates what we call the arrow of time. For a long time, this was accepted to be a product of thermodynamics. The second law states that entropy, or disorder, always increases in a closed system. The egg breaks because there are infinitely more ways for it to be broken than for it to be whole. Therefore, we assume time moves forward because the universe is moving from a state of low probability order to high probability disorder. But here is the catch. This thermodynamic arrow is a statistical law, not a fundamental one. It applies to large crowds of particles, what we call macroscopic objects. But what happens when you zoom in past the shell, past the molecules, down to the individual quantum states in the microverse? In this microscopic realm, the statistical crowds disappear, and the rigid arrow of time begins to wobble. Recent evidence suggests it actually splits in two. This brings us to the breakthrough from early 2025. A team of physicists at the University of Surrey, led by Dr. Andrea Rocco and Thomas Guff, published a study in Scientific Reports that fundamentally challenged the inevitability of the time arrow. Previously, physicists believed that while isolated quantum particles might be time symmetric, as soon as they interacted with the outside world, known as an open system, the environment would act like a heat bath, sucking away information and forcing the system into a single, forward-moving timeline. The environment was thought to be the enforcer of the second law. The Surrey team decided to test this by looking at the mathematical models of open quantum systems, without the usual bias physicists add to simplify the math. They analyzed the Markov approximation, which is a standard tool used to describe how quantum systems lose energy to their environment. Usually, this approximation is applied in a way that mathematically forces time to move forward. It is a self-fulfilling prophecy. We assume time moves forward, so our equations show time moving forward. When the Surrey researchers stripped away this bias and treated the interaction symmetrically, they discovered something startling. The equations did not break. Instead, they revealed that the system could evolve towards equilibrium in two directions. One path moves forward in time, increasing entropy into the future. But there is a second path that moves backward in time, increasing entropy into the past. They found that the microverse allows for dual temporal flows. From any given moment, a quantum system sees two diverging paths. It is not just pushing into the future, it is also pushing into the past. The apparent one-way flow we experience is not a law of quantum mechanics, but a result of our specific perspective, a perspective illusion similar to how the Earth looks flat from the ground but round from space. This was the smoking gun, proving that time reversal symmetry is preserved even in dissipative open quantum systems. While the Surrey study provided the mathematical proof, the theoretical framework for this dual time has been arguably the most provocative underground theory in physics for decades. It is known as the Two State Vector Formalism, or TSVF, championed by Israeli physicist Yakir Aharonov. To understand TSVF, we have to abandon the idea that history is written in ink. In standard quantum mechanics, we describe a particle using a wave function that evolves from the past to the future. If we know the state of the particle at noon, we can calculate the probabilities for 1 minute past noon. TSVF argues this is only half the story. Aharonov proposed that a quantum system is described by two wave functions. First, a history vector coming from the past, which is what we are used to. But second, a destiny vector coming from the future. The reality of the particle right now is the result of a handshake between these two vectors. Imagine you are watching a movie. Standard physics says the frame you see now is caused by the previous frame. TSVF says the frame you see now is the result of the previous frame meeting the next frame. The future is partially determining the present. This implies retrocausality, the idea that future events can influence past events. In the classical world, this creates paradoxes, like the grandfather paradox. But in the microverse, it resolves mysteries. For example, consider the inherent randomness of quantum measurement. If you measure a particle's spin, the result might seem random to you, because you only know the past vector. But if you knew the destiny vector, which is the result of a measurement that hasn't happened yet, the outcome would be deterministic. The randomness is just our ignorance of the future. This destiny vector flows backward, carrying information from the future to the present, guiding the quantum probabilities of the microverse. Now, theoretical math is one thing, but physical evidence is another. In the last few years, the rise of quantum computing has given us the tools to manipulate the microverse directly, leading to experiments that effectively reverse the arrow of time. In 2019, a team from the Moscow Institute of Physics and Technology used an IBM quantum computer to perform a time reversal operation. They set up a system of qubits to simulate an electron scattering, a process that normally increases entropy. The qubits evolved from an ordered state to a chaotic, entangled state, following the standard forward flow of time. Then, they applied a special reversal algorithm. This algorithm acted like a mathematical mirror, inverting the phase of the quantum states. When they resumed the system's evolution, the qubits did not continue to get more chaotic. Instead, they unscattered. They moved from chaos back into order, perfectly reconstructing their initial state. To an observer inside that quantum system, time had run backward. The shattered egg had reassembled itself. This proved that the information of the past is not lost in the microverse. It is merely scrambled, and with the right key, it can be unlocked and reversed. Furthermore, experiments using nuclear magnetic resonance and correlated quantum particles have demonstrated the reversal of the thermodynamic arrow. In classical physics, heat always flows from hot to cold. However, by creating a specific quantum correlation between two particles, scientists were able to make heat flow from a cold particle to a hot particle, making the cold one colder and the hot one hotter. This is a local violation of the second law of thermodynamics. It works because the correlation between the particles acts as a fuel source that pays the entropy tax. But for the duration of the experiment, within that tiny pocket of the microverse, the thermodynamic arrow of time pointed backward. We have also seen verification of TSVF through the quantum Cheshire Cat experiment. Aharonov and his colleagues proposed a scenario where a particle and its property, like its spin, can be separated. This phenomenon can only be fully explained if the future measurement influences the past separation. Recent experiments using weak measurements, a technique to gently probe a quantum system without collapsing it, have confirmed predictions made by TSVF that standard quantum mechanics struggles to explain. These experiments show that particles effectively know what their future measurement will be and adjust their behavior in the present accordingly. So what does a universe with dual temporal flows look like? If we could shrink down to the Planck scale the pixels of the universe, we would see a roiling foam of time. In this quantum foam, virtual particles pop in and out of existence. With dual time flows, these particles can be seen as loops in time. A particle moving forward in time that suddenly turns around and moves backward in time appears to us as an antiparticle. Richard Feynman famously proposed that antimatter is just ordinary matter moving backward in time. The Surrey study and TSVF give this idea renewed weight. The microverse is a busy intersection of traffic, with matter flowing towards the future and antimatter or destiny information flowing towards the past. This leads to the concept of the eternal now. If the past and future are interacting to create the present, then the present is not a fleeting moment. It is a standing wave. Think of a guitar string. When you pluck it, waves bounce back and forth between the bridge and the nut. The note you hear is the stable standing wave created by the interference of these opposing vibrations. In the microverse, reality itself is a standing wave created by the interference of the past vector and the future vector. Existence is the harmony between what was and what will be. You might wonder, if the microverse allows for dual time flows, why does our macroverse only see one? This brings us to the Janus point hypothesis. Named after the Roman god with two faces, this theory suggests that the Big Bang was not the beginning of time, but a midpoint. On side A, which is our universe, time flows in one direction where entropy increases. On side B, the mirror universe, time flows in the opposite direction. Entropy increases away from the Big Bang, which is their past but our future, relative to the singularity. The Surrey study supports this by showing that bidirectional arrows naturally emerge from equilibrium points. The Big Bang was the ultimate equilibrium. From that moment, two temporal arrows shot out in opposite directions. We are simply riding one of them. The dual flows we detect in the microverse are the residual echoes of this fundamental symmetry. The confirmation of dual temporal flows is not just philosophy, it is engineering. We are looking at the future of time technology. One major application is error-correcting quantum computers. The greatest enemy of quantum computing is noise, or decoherence, which is essentially the forward march of entropy disrupting the delicate qubits. If we can harness time reversal protocols like the IBM experiment, we can effectively rewind errors. By periodically reversing the temporal flow of the qubits, we can undo the damage caused by the environment, creating stable, error-free quantum processors. Furthermore, if TSVF is correct, there is information flowing from the future that is accessible now via weak measurements. This suggests we could build temporal sensors for quantum states. We could measure the destiny vector of a particle to know its final state with 100% certainty before the final measurement occurs. We are moving toward a computation model based on teleology, or purpose and destiny, rather than just causality. Algorithms could be designed where the answer in the future helps compute the question in the present. In conclusion, the evidence is mounting that the linear river of time is an illusion of our size. Deep in the microverse, the distinction between past and future blurs. We find a reality where two great currents meet, a flow of causality from the past and a flow of destiny from the future. The Surrey study has given us the math, the IBM experiments have given us the proof, and the two-state vector formalism gives us the map. We live in a block universe, a four-dimensional crystal, where the past, present, and future exist simultaneously. The flow we feel is just our consciousness crawling along the facets of this crystal, but down in the quantum basement, the crystal is transparent. The future is already there, shaking hands with the past, and we are the standing waves singing in the middle. The arrow of time is not a tyrant, it is a guide. And for the first time in history, we have glimpsed the path leading back.